All right, good morning, everybody. My name is Elliott Wickham. I am the Southeast News Coordinator for NOAA's NITUS. Thank you for joining us today for our Southeast Monthly Climate Webinar. Today we are going to have, we're joined by Chip Konrad with the Southeast Regional Climate Center, giving the climate overview. Also joined by Shelby Saxon with the Southeast River Forecast Center, giving the water resources overview. And then we have our special topic presenter today, Jason Elliott from the National Water Center, going over the National Water Center's water resources, services, and support. Please type your questions and comments using the Slido app at any time, and they will be answered at the end. And a recap email will be sent to all registrants with a YouTube link to this recording later this week. To use the Slido app, if you're in the browser, click the apps down there at the bottom, type in your question, and then press the send button. If you're in the app, click Slido down at the bottom, and then type your question in and press the send button. Now I'm going to turn it over to Chip to give the climate discussion and overview.
Okay, thanks, Elliott. And so we're going to start off here today looking at temperatures month to date, and this goes through Saturday. And if we look there at the anomalies and the coloration there, you see a lot of yellow, which indicates month to date temperatures equaling or exceeding 3 degrees. And the rest of what you see there is white. I think there may be one orange up there, but we basically continue to have above normal temperatures. And if we look at the map on the right there with the rankings, and if you pay attention to the reddest colors there, we had places that had record warm temperatures for the month. And you recall going back to June. June was a very warm month as well, so we're continuing the trend. Amongst the places that were warmest on record includes Reidsville, North Carolina, Marion, South Carolina, North Myrtle Beach, Hartsville, South Carolina, Lakeland, Florida, Fort Lauderdale, and also several locations in the Caribbean. Next slide. Looking at precipitation here, as it is typically the case in the summertime in the Southeast, there's tremendous spatial variability. So we had places that were very dry. As you can see there in terms of the percentiles, you see a number of browns there. And then we see there the reds. There were places that were quite wet. In terms of places with very wet starts, a lot of this has been in western North Carolina and parts of, I think, far southwestern Virginia. CeeLo, North Carolina, picked up 13.12 inches. And again, this is just so far this month. Concord, North Carolina, nearly 12 inches. Richlands, Virginia, slightly over 9 inches. Galax, Virginia, and Martinsville, Virginia at 8.34 inches. In polar contrast to this, there are a number of places that had very dry starts, again, up through the 25th. Valdosta, Georgia, Valdosta, only 92 hundredths of an inch of rain. Brooklet and Statesboro, Georgia, 1.3 inches. Columbia, that should be South Carolina at 1.38 inches. And Elberton, Georgia at 1.49 inches. Next slide. So we're still dealing, even though we've gotten, some areas have gotten quite a bit of precipitation over the last month, we still have quite a few places that have a very significant long-term precipitation deficit. And so if we look at precipitation for the water year, so this would be October 1st going all the way up to the 25th. And we can see here, and we'll just focus here on the right, is up through July 25th. Quite a few places are still very dry, indicated by the brown. So any of the browns that you see there are 10th driest or greater. And there's still places that have the driest, have the lowest precipitation on record for the water year. That includes Charlottesville and Danville, Virginia, North Myrtle Beach, South Carolina, Savannah, Georgia, Gainesville, Florida, and also Tampa, Florida. Next slide. Okay, so going over here to the monitor, given the continued dry conditions in places, we've seen drought still really bad in some places. And if we just look at the map there on the left, in the southeast, we still have places that are in D3, D4, indicated by the red going into the brown. There are two particular places that are in D4, a little area there in basically the northern part of central North Carolina, and another area in the extreme tip of North Carolina there. But one thing that's been fortunate, typically this time of the year where some places are really getting dry, but over a lot of areas, if you look at the map on the right there, the 5-week class change, a lot of areas are light green, which indicates a 1-class improvement, so becoming a little bit less droughty. And you see a few places, particularly up there in Virginia, far southwestern Virginia, that have seen a 2-category improvement there. So these are places that a number of these have gotten significant rain over the month, and they're improving. Unfortunately, we have some places in which the drought is getting a bit worse, and basically the southern part of North Carolina and the eastern portions of the eastern half of South Carolina, at least some of those areas there where there's been a 1-class degradation. And then also sticking out there, South Florida, which is getting a little more droughty, and also southeastern Alabama, where some of those areas haven't gotten much rain over the last month. Next slide. Over in the Caribbean, a lot of the area is experiencing drought right now. And so looking at the map there on the left, you can see that there's basically moderate drought and severe drought happening on the south shore there of parts of Puerto Rico. There's one small area that doesn't have any drought, but the majority of Puerto Rico now has drought. And we look at the change over the last 4 weeks or so, there's been increasing drought there. And in some areas, there's been a 2-class degradation there in the drought. Next slide. Okay, so sea surface temperature anomalies across the world here. I put this up here just to show you that the vast majority of the ocean, and of course we're on the water planet, temperatures are above normal, indicated by yellow all the way up to the very dark red there. And what you can really see standing out there is the emergent El Nino that everybody's heard about there in the equatorial Pacific. So sea surface temperatures are really getting above normal in that area. And we officially have an El Nino that's happening now. Okay, next slide. And so this chart here shows the probabilities of El Nino strength here. And this was issued just a few weeks ago and will be updated. But if you look at the really dark, basically the dark red bar there, and you look at the legend there, very strong El Nino, and you can see that the probabilities of a very strong El Nino really go up. And then in the October, November, and December frame, OND there, you see on the bottom, if you look at it really closely, it indicates there's about an 81% chance now that we're going to have a very strong El Nino. So it looks like this is really happening. And there's some models that show sea surface temperature anomalies getting somewhat warmer even than the 2 looks like the 2 degree Celsius range there. Okay, next slide. Okay, and so that brings us to the Atlantic hurricane season outlook. The last outlook issued by NOAA was back in late May, and it showed a 55% chance of below normal conditions, 10% chance of above normal, 35% chance of being normal. And so with that, they're predicting basically 8 to 14 named storms. The average for a year is 14. So definitely you see they're projecting fewer storms. Hurricanes, 3 to 6 hurricanes where the average is 7, 1 to 3 major hurricanes where the average is 3. Obviously, this relates a lot to the El Nino conditions in the equatorial Pacific. That creates vertical wind shear over the Atlantic and also quite a bit of subsidence. And so that really inhibits hurricane activity. Next slide. Okay, so let's move into the outlook here. So for the next 3 months here, so this would be the period August through October, we see over the southeast somewhat higher probabilities of getting above normal temperatures, especially in the southern half of Georgia, Alabama, and all of Florida there. In terms of precipitation, much of the area is expected to receive precipitation in the normal range. That's where the odds are the highest. You see that area of green there, the Ohio River Valley and the Tennessee River Valley. Some of that, of course, creeps into the southeast. So there's a little bit of a higher chance of getting above normal precipitation in that area. Next slide. Across the Caribbean, 3-month outlook, pretty simple, really. Above normal temperatures and unfortunately below normal precipitation. And so that correlates very much with the El Nino signature, having fewer tropical systems, and also just generally having drier air, which we've been seeing across much of the subtropical Atlantic here. Next slide. 3-month drought outlook. The drought is expected to persist across much of the Carolinas there. You see in the brown shading. There's some areas where drought removal is likely, just some fringe areas around Tidewater, Virginia, and a few other areas, but a lot of the area that's not in drought is not expected right now to go into drought. In Puerto Rico, the drought is expected to persist on the southern and the eastern sides of the island. That includes also the U.S. Virgin Islands. And again, that just doesn't really bode well with the El Nino coming in. It looks like it's going to get even drier there. Next slide. Okay, so in terms of precipitation over the next 7 days, quite a bit of precipitation you can see there is indicated by the hot colors, the reds and the oranges, down along the Gulf Coast area, extending into Florida, and then also kind of on basically the eastern halves of North Carolina, South Carolina, and Georgia, and Tidewater, Virginia, expected to get basically over 1.5 inches or so of precipitation. So kind of on the wet side for a lot of places, but if you look closely at the map, big part of central Virginia and west central North Carolina, maybe precipitation will be a little bit less than what you would expect for the next 7 days. Next slide. Okay, I thought I would throw this slide in here. There's been a lot of talk about the wildfire smoke, and most people think the wildfire smoke is coming from Canada. The reality is the smoke that we've been experiencing here recently, the vast majority of it is coming from Oregon and Washington State. And so you can see the map there on the left. The size of the circle indicates the number of acres that are currently burning right now. And if you look at the map there on the right, it's showing the smoke that's coming from those fires. And this is actually a prediction for 4 o'clock this afternoon. But anyway, you see just a broad area of brown, and you see really just about the entire southeast experiencing some wildfire smoke. If you've gone out and looked at the sky over the last couple of days, you notice that it's really hazy. Fortunately, that smoke is all at a higher elevation, and so it's not degrading air quality in any way. But we've had some troughing over the eastern U.S., and so the mid-levels, there's been a lot of northwesterly flow circulating that wildfire southeast, and that pattern is expected to continue at least through the next week. There's another trough digs into the Midwest. Next slide. Looking ahead, the next 6 to 10 days in terms of temperature, much of the area is expected to see above normal temperatures, though you see an area there centered in Alabama and western Georgia where temperatures are expected to be closer to normal. And this relates probably to cloud cover and rain more than anything, more than getting some cool air coming down from Canada. And we go and we look at precipitation. All the areas expect to see a little bit higher than normal chances of getting above normal precipitation. Next slide. Very similar pattern for the 8 to 14 day, although now all the areas expected to see above normal temperatures. Precipitation is expected to be close to normal across virtually all of the area except northern Virginia and the DC, where there's a slight chance of above normal precipitation. Next slide. And so the next 3 to 4 weeks, temperatures expected to be above normal. That seems to be a repeating record here, especially if we look down there in Florida That's where the probabilities are highest that we'll see above normal temperatures there. In terms of precipitation, equal chances of above or below normal precipitation, except for South Florida, places where they're really needing it down there. There's some chance of getting below normal precipitation. Next. Okay, so here's a summary. I won't read this out. And so I think with that, I will turn it over to Shelby Saxon.
Thank you, Chip. And we can go ahead to my first slide. And so, as Chip said, over the last month, rainfall has mostly been normal to about 3 inches below normal across the southeast. In the Mobile area, where we saw much above normal rainfall back in June, this month we actually saw deficits up to 6 inches. And so, given the above normal summer temperatures and the long duration dryness that we've been seeing in the southeast, about 42% of the river gauge locations that are shown here on the left are below normal. Now we can go to the next slide where we'll look at our state duration hydrographs. And just as a reminder, these are provisional since the decommissioning of Water Watch by the USGS, but we'll still use these to look at our runoff trends and how our stream flows are. And so we can see a negative trend across Alabama, Georgia, and Florida, mostly due to the warm temperatures and below normal rainfall. Alabama had reached the 90th percentile for runoff, and this high evaporation and low rainfall period that we are currently in is kind of only resulting still in normal flows and is not kind of trending towards the below normals that we see both Georgia and Florida heading back into. So Georgia did see substantial rainfall at periods, but it wasn't as widespread. And so in our state average, that is where this negative trend is appearing. And then in Florida, we are currently in the rainfall season. And so we expect the state to be much wetter. And so heading now into some of the lower percentiles because of the lack of rainfall there. And we can go to the next slide. And so the spring brought flows in the Carolinas and Virginia from record lows into the 5th to 10th percentiles. But the June runoff was mostly a decrease in these states or stayed constant. And so July has been more variable for what we see in terms of stream flow across these three states. In North Carolina and Virginia, we recently saw some above normal rainfall. And so we're seeing sharp positive trends in the runoff there. In North Carolina, flows are mostly, or in North Carolina, we're seeing our flows the most normal than they have been since November. And so just showing that we didn't really reach the normal flow during our wet season or the early spring period. In Virginia, we're seeing some response now and still only reaching about the 24th percentile. South Carolina had just enough rain over the month to hold flows near the 5th percentile, and so we're still looking at below normal flows in South Carolina. We can go forward to the next slide. So taking a look at our current river conditions, we do not have any flooding occurring. In the past month, we have seen some localized heavy rainfall that was able to produce action and minor stage floods in Georgia and actually in North Carolina recently. Those heightened flows were very short duration, and we have since seen everything returning to normal or below normal in terms of flood stage. We can go to the next slide where we'll take a look at what we typically see in our river climatology right now. And so we are in week 31 of the year, and it is typical to see some minor floods. And these are mostly right now due to the systems that set up and bring us some of our heavy convection. And so, like we saw in the past month, just a few minor floods due to frontal systems moving over the area. Over the next few weeks, the potential for flooding typically remains the same, and then we don't see an increase in the potential for minor or damaging floods until we get to about the peak of the tropical season in the southeast. And so on the next slide, we'll take a look at Florida. As we mentioned, the rainfall season is currently ongoing, and it's typical that we would see minor river flooding over this time. We have not seen any flooding to date this year in Florida. Um, just still recovering or attempting to recover through rainfall from the long duration dryness. And over the next few weeks, it's typical that we would see more minor floods in Florida. And it's again not seeing some of our moderate and major flows until we reach the peak of the tropical season. And on the next slide, we look forward to the risk of river flooding from August through October. And so the peak of the tropical season will fall within this period. But as we've heard, the Hurricane Center is predicting a below normal season because of the ongoing El Nino. This forecast, in combination with the dry and acidic conditions, does make us lean toward below normal risk for river flooding in the Carolinas and Florida. That doesn't mean that there is no risk for river flooding. If we were to see a stalled front over a long duration or have a tropical system move over or near these areas, that could change the flood risk and produce some flood potential on our rivers. And although the soils, as we just saw in Alabama and Georgia, are trending towards drier conditions, we are still in that normal range. And so that the current conditions in combination with the possibility for continuous convective showers has us keeping both of these states in a normal risk for river flooding over this next period. And we can go to my next slide, which I believe is the summary. And so overall, below normal stream flow is continuing, and we especially see this in our headwater reaches. There have been periods of relief, but things are drying out quickly after we do see some of our heavy rainfall events. And this slide will be available to you in the recording if you'd like to return to it. And so with that, I will pass it over to Jason from our National Water Center.
All right, Shelby, thanks. Good morning, everybody. I appreciate the opportunity to speak with you today. I'm Jason Elliott, the Service Coordination Hydrologist at the National Water Center in Tuscaloosa, Alabama. I'll be providing a brief overview of what we do in National Water Center operations. Now, I won't be able to get into a lot of details on any one topic, obviously, this morning, but if something strikes your interest, please do reach out to me. I can almost guarantee you that we have additional information to share on any given topic. On the next slide, I want to start by telling you just a bit about National Water Center operations. As I mentioned, we're located in Tuscaloosa at the National Water Center, and our mission in operations is to provide timely, actionable hydrologic intelligence. We operate 365 days a year from 5 a.m. to 8:30 p.m. Central Time. But during significant events, we do extend our hours. That's something that we did recently during the flooding in Texas. We stayed open late as that was ongoing. Or on rare occasions, we'll stay open all night, 24 hours, in support of a significant regional scale hydrologic event, particularly a tropical cyclone, although it could be something else of a regional scale that would cause us to be open 24 hours. On the next slide, I'll tell you what happens on a typical day in National Water Center ops. There's a lot here, so I'll just cover the highlights. When the morning shift arrives at 5 o'clock, they'll take stock of where everything is. They'll look and see if any new or updated episodic products are needed. I'll talk more about what those are in a moment. And they'll develop the morning flood hazard outlook and the associated discussion, which I'll also talk more about in just a moment. Then our team meets daily with the forecast team at the Weather Prediction Center to compare notes on forecast rainfall and what we expect that rainfall to do hydrologically, so that we're kind of on the same page and coordinated in that regard. That's followed by an internal operations briefing that actually just happened here at the Water Center a few minutes ago. The rest of the day shift is then spent keeping watch over hydrologic conditions, as well as the services that the National Water Center provides, the status of those services, and conducting assessment of flood inundation mapping as needed. Then the morning team will start to pre-stage information to set up the oncoming shift. And when they arrive just after midday, they'll hit the ground running the same way the morning shift does. They'll check for any updated products that are needed. They'll put the finishing touches on the afternoon flood hazard outlook. After that, they develop reports and daily summaries, start to wrap the day up, and then pre-stage information for the next day's shift to be ready to go when they arrive. In addition to all that routine stuff, we may be asked to present on briefings with national level federal partners, fulfill data requests, public and media inquiries, collaboration calls, and anything else that may come up during the course of a day. Next slide. Now let's focus on the primary products that are produced by operations, and there you see them. The flood hazard outlook is the keystone product of our national operations, serving as the national overview of potential flood impacts of all freshwater flood types during the next 7 days. More on that in a moment. The area hydrologic discussion is an experimental product that would be comparable to the mesoscale precipitation discussion from the Weather Prediction Center or the convective discussion from the Storm Prediction Center, intended to provide a semi-local overview of what rain might do from a rapid onset flood perspective when it hits the ground. More on that in a moment too. And then the National Hydrologic discussion is our text-based forecaster discussion. On the next slide, I'll get into more detail on each of these in order. Our flood hazard outlook is issued twice a day routinely, 7 a.m. Central Time, and then in the mid-afternoon time frame, 3 p.m. Central Time most of the year. Why does that afternoon time move around? Well, we purposely time that so that it can go out and be available to you as soon as possible after all the information we need to make it is available. And during standard time, that's earlier in the day, so we don't wait, we just go ahead and put it out an hour earlier. We use 3 impact categories in the outlook as shown in the triangle graphic on the left side of the screen. Limited, our lowest category, is a bit of a catch-all if you read the fine print there. It mentions that there is potential for more significant impact than just a limited impact. So here's how I will tell you to look at it. In the flood hazard outlook, the goal is not to capture every significant flood in a higher category, but to capture more significant events that occur in those higher categories. The 2 higher categories purposely carry the considerable and catastrophic names, which are the same as what you would see in a flash flood warning, and they loosely convert to the 2 higher categories of stream flooding, moderate and major as well. The primary flood hazard outlook is a conglomeration of flood risk throughout the next 7 days. So what you see there on the graphic on the top right is the full 7-day outlook. But in reality, we're producing 2 different time slices, days 1, 2, and 3 put together, and days 4 through 7 put together. Although you don't see that on this graphic, if you scan the QR code that's on the screen, you'll go to an interactive map where those individual time slices are available. And we have plans to split those time periods into additional slices in the future, primarily splitting days 1, 2, and 3 apart. I should also note here that when a tropical system affects the continental United States, Hawaii, Puerto Rico, or the U.S. Virgin Islands, and we expect there to be flood impact from it, we provide a separate additional visualization of the outlook that you see there at the bottom right. That's actually the one from Hurricane Ian. It contains the same information, so there's nothing graphically different. It's just zoomed in on the area where the tropical impacts are expected. But there is a lot of additional information in the text on the left that further specifies the potential impacts And it also points people to the National Hurricane Center for the storm surge details that we don't get into on the freshwater side. Next slide. I want to peel back a few layers of the onion on how we create the FHO. This slide says that over 25 considerations go into the determination of the flood impact categories. I recently asked our forecasters to recatalog that, and they came up with over 40 instead of 25, just for the first 3 days of the outlook alone. Some of the key ones, though, are shown in the schematic on this slide, including obviously precipitation forecasts, soil conditions, the things that you saw in Chip and Shelby's briefing just a moment ago. Some others that aren't shown here, depending on location and time of year, would include winter-related input, remote sensing information, inundation mapping, and others. The key thing to keep in mind here is that the flood hazard outlook is all about potential impact and the overall severity of the impacts of an event. And although probabilistic considerations go into developing the outlook itself is not currently probabilistic. But as advancements occur in all the inputs, that very well may change in the future. Next slide. I briefly do want to mention that we determine inclusions to the flood hazard outlook based on what are called hydrologic unit code boundaries, or HUCs. Water doesn't follow geographic boundaries. In fact, quite often, as we know, water is the geographic boundary. So that can cause a problem, and nor would it follow a hand-drawn boundary. So to be as hydrologically accurate as possible, we use HUCs to determine what's in or out of an impact category. Obviously, if rain falls on one side of a basin and it's not going to get to the other side of a basin, the impact won't be the same. The graphic on the right from the USGS shows how you drill down from a large area to a smaller one. And the table on the left will give you an idea of the average size of each level. We can use the 4 middle-sized areas that are highlighted in yellow in our outlook development. Next slide. Last fall, we launched zoomed maps for the outlook that are available at the state, RFC, and FEMA region scales. They're available at the link that's shown at the top of this slide. That link is publicly available, but right now is relatively unadvertised. I say relatively because if you go to your favorite search engine and search for FHO zoomed maps, it comes up. We do expect to make that link better advertised and more prominent soon, but they are available for use today, and they include those individual time slices of days 1 through 3 and 4 through 7. If you need to pull that out for a specific area, you can get the specific time slice and the zoomed in area together. Next slide. As I mentioned earlier, if you want to know why something was or was not included in our outlook, you can read our forecaster discussion, which we call the National Hydrologic Discussion. If you have seen this product before, say a year or 2 ago, it was actually very different than it is today. Today, it actually is the forecaster reasoning behind the outlook. It used to just be a scientific-based laundry list of everything that was going on hydrologically in the country. Now it really is tied to the outlook and gives explanations about the outlook. We issue this alongside the outlook every time it's issued, and it's available at the link that's shown on this slide. It is relatively plain language. There are some doses of scientific information where they are needed for explanation, but it's a relatively easy read. And like I said, it's intended to get you in the minds of our forecasters to understand why something was or was not included. Next slide. And then last but not least, the area hydrologic discussion. Really, when you look at the definition of this product, it's primarily intended for forecasters in the National Weather Service who are in the chair making watch and warning decisions during a hydrologic event. But we make this available to everybody. The intent is to highlight areas where there could be potential rapid onset flooding, largely based on output from the National Water Model, which I'll talk about in a moment. But the area hydrologic discussion doesn't have to be based on water model output. But what we provide here is semi-scientific. So if you're looking for a plain language product on flood risk, this isn't it. But if you know kind of hydrologic jargon and lingo, it can be very useful. And we do try to, toe a little bit of a line between the highly scientific and the plain language in this product. The one you're seeing on the screen is the one we issued during Helene, right before things went south in the Asheville area. So it does have some wording there at the bottom specifically talking about Asheville and the small streams that flooded before the big streams that flooded. Next slide. Last year, we also began, along with all the other national centers in the Weather Service, issuing key messages graphics. This is an example of one of them. There's actually one out right now for the significant flash flood potential in the Philadelphia to New York City corridor. So if you go to the link at the top right of this slide, today, as we're doing this, you'll see one live. If you're watching the recording, there may not be one out at the time that you're watching the recording. We issue these for significant flood hazards. Usually it will be if we have considerable in the flood hazard outlook over multiple states, like the one that you see here. It can also be issued like the one for today, a moderate excessive rainfall outlook that includes a major metropolitan area. Again, they're available at the link at the top right here. And we don't duplicate other key messages. So if there was a tropical cyclone, the Hurricane Center does key messages for that, and they include the flooding as part of theirs. So we wouldn't do a separate one in that case. Next slide. Now I'll turn for just a moment to the National Water Model. And the intent of that model is to give you something for guidance on the millions of river miles that aren't already forecast by the river forecast centers. The National Water Model is still a relatively young modeling system, but since its inception, there have been improvements along the way, expansions to areas outside the continental US, and additional enhancements are in the works. Next slide. Here's an example of how the water model itself can help and some of the ways that we use it. The image shown here is the Charlotte metro area. You see there are 3 long-standing, well-modeled, well-forecasted river forecast points in the Charlotte metro. They're telling you what's happening on the streams where they reside with high-quality, accurate forecasts. But on all these other streams that aren't those 3, including where a lot of people live, there aren't those forecasts. So that's where the water model comes in with, again, guidance. It's not gospel, but it's guidance and information that can be used. There are different ways you can use it. One of the things that I use a lot of from the water model is what's called peak flow arrival time, which I don't have an example of in this presentation, but it's a way to know when the highest water levels are expected based on what the model output shows. And that's even if you don't know the magnitude of that water, if you have a timing thing to go by, that can help you just by itself to know when the worst would be expected. Next slide. There are several ways to view National Water Model data. One of them is by going right to a location on water.noaa.gov, which I'll talk more about in a moment. This is one example from 2024, and of course we picked a good one to show you that shows the output from the water model at a forecast point location from a river forecast center. So the purple line, the dark purple line with the squares is the official forecast from the river forecast center. The lighter purple lines are the water model forecasts. And you can see there, they're tracking pretty close. The recession from that first peak is faster in the model than it is in the forecast, or really in reality either. But they're both showing that second peak that happens a few days later from the next rain event. Next slide. Let's turn now to flood inundation mapping. And the need to put water on a map is not at all new. It's something that's been known for at least 30 years now, but technology in 1996 wasn't what it is today, obviously, and it wasn't easy. As with so many other things, technological advancements during that 30-year period have allowed for inundation mapping at individual locations first, communities who paid to have mapping done, dams who had paid to have mapping done for their emergency action plans, things like that. But it was one location here, one location there. It wasn't at scale. In 2017, though, the National Water Center's Summer Institute demonstrated the capability to scale it to a national level. And over the ensuing years, that capability has been built out, enhanced, and expanded, leading us to where we are today, which is being less than 2 months away from inundation mapping being available at scale for nearly everyone in the United States. Next slide. This is a map of the rollout in the Southeast. I cut Virginia off, but Virginia is already all public and the rest of these states are not. Why was there a rollout? Why wasn't it just all released at once? Well, first of all, training people on using these maps, how to use them, how not to use them, how to analyze them, how not to analyze them, is a process. It's something that when this was first available, even we didn't know. And we've learned a lot during the course of the rollout. People who are in the rollout that's going to happen in a couple months are way ahead of those of us who were part of the original rollout back in 2023. So that rollout did happen in phases to kind of get people trained up and let the advancements happen as we go. The maps that are coming out this September are better than the ones that came out in September of 2023 in a lot of places. So Tennessee, Alabama, Mississippi went live in 2024. The rest of the Southeast outside of the Atlantic coastal plain went last year, and then the Florida Peninsula and the coastal plain go live in September of this year, late September, and that'll complete the rollout nationwide, except for parts of Alaska and the Pacific Islands, which won't have them during this phase. Next slide. These are the 3 different flavors of publicly available inundation mapping that you can find on water.noaa.gov. One is an analysis of what is most likely happening at this current hour. So it's available everywhere FEM is available on the map. You go to water.noaa.gov, you turn on inundation, you turn on the analysis, and you'll see every place that has inundation forecasted by the model at that time. There are also 2 forecast versions. One is tied to the locations where our river forecast centers provide routine forecasts that are above flood, and the other fills in the gaps in between for the entire country based on the National Water Model. In both of these forecast cases, and for that matter for the analysis case, if no inundation is expected, nothing draws. You won't see the river filled in with inundation unless it's above the threshold where some inundation of actual land is expected. Also, I should note these maps are extent only at this time, and they're also only for freshwater flooding at this time. Both depth and total water levels are in development as future enhancements. Next slide. What I want to do really briefly is take you through a couple examples. In this first one, we're looking at National Water Model inundation mapping for a small ungauged stream near Myersdale, Pennsylvania. So again, no gauge, no other forecast available. But this was a significant river flood event that occurred on May 13th, 2025. As we slowly advance through these pictures, you'll see circles on the map popping up on the left and corresponding pictures of those same locations on the right. And for each one, you'll notice a relatively close resemblance of the photos to the extents that apply to them for each one. Not a perfect match, and we wouldn't expect a perfect match. What we're really expecting here is a neighborhood level match, and in each of these cases, we generally do get that throughout the course of this event. And there's that last picture is actually off the map, but it's a tributary that flows into town from the east. Next slide. In the second example, we're looking at a flash flood event that occurred overnight, also in 2025, also in Pennsylvania. 4 to 6 inches of rain fell in 12 hours. And here, the National Water Model analysis inundation mapping is shown. And we see from the photo that's attached here and the circled buildings that the analysis FEM is doing a pretty good job, especially near the yellow circled building. You can see if you look real close in the photo that the water line is very close to that building in the photo. It's also right on that same line or very close to it in the inundation map. So another case where it worked out really well. And we've got a number of these cases, both good and bad, where we've been able to compare the inundation mapping and the photo. So if you have photos after an event, get them to any of us in the Weather Service, whether it's at the RFC level, the WFO level, or here at the Water Center. We use those to help make the mapping better and validate the mapping to improve it going forward and get that to the developers. Next slide. To start to close this out, I want to touch on a couple special topics. First is our Emerging Water Resources and Extended Range program. We collaborate routinely with the forecasters at the WPC Extended Range on including flooding possible in their day 8 to 14 hazards outlook. Our guiding principle is this: when we put an area in our outlook, the flood hazard outlook, on day 7, based on what we know right now? If yes, then we collaborate with them to get it in the 8 to 14, as you see on the example from last summer in the Southwest. They also include rapid onset drought in their day 8 to 14 hazards outlook. Generally, we're not currently collaborating on that, but as more resources related to hydrologic drought are becoming available, we expect that may be another spot where we provide them input in the future. We're also expanding our overall dry side focus beyond week 2 into the week 3 to multi-month timescale. That's still in the exploratory phase, so I don't really have more details about that quite yet, but I do expect some advancements in the coming months and years in that regard, and hopefully we'll be back to talk to you more about that in the future. Next slide. And lastly, I want to mention our overall online presence. For many years, the National Weather Service's web presence for hydrology was known as AHAPS, the Advanced Hydrologic Prediction Service, which was housed at water.weather.gov. But over the years, as additional resources were developed and deployed, the information got spread across all 3 of the websites that you see here, making the AHAPS site less of the one-stop shop that it originally was for water information. Often you had to go to all 3 of these sites to get a complete picture, and none of them really linked to each other very easily. Next slide. That led to the launch of a new gateway for water information called NWIPS, the National Water Prediction Service, at water.noaa.gov. NWIPS integrates the information from those 3 sites shown on the past slide, plus some new things that have recently been added, back into a mostly one-stop shop for water. But it also was an improvement and modernization from those older sites, more mobile friendly, easier to use features in navigation, more like a GIS type dashboard. It was harder to use for people who weren't used to this new way, but the information is easier to get at, easier to bookmark, and as I'll show you in a couple minutes, easier to integrate into other applications. Next slide. But possibly most important of all, the new system allows the long-standing forecast data from our river forecast centers and the observations from the USGS and other partners to be right alongside the map of what that water is likely to look like on the ground, on the same screen for the first time. All in one place, relatively easy to get it set up that way, and then as I mentioned a moment ago, easy to bookmark that link and have it come back up the same way the next time. Next slide. And all of this is driven by an application programming interface, or API. That means that it's possible to leverage that API to integrate the information from our services into your own tools. I obviously can't cover that in this time together, but there's a QR code here to view an API webinar that was produced, and the link at the bottom of this slide goes directly to the documentation. And if I'm being completely honest, your favorite AI assistant can probably grab this information for you from the API without you having to do a whole lot. A lot of those assistants seem to know exactly how to get at the information and get it pulled out the way it needs to be available to you. Next slide. Snap a quick photo of this slide or take note of these links. It's possible in NWIPS to get to specific National Weather Service Office service areas, states, or individual locations. And then bookmark those to be able to get directly at what you need. Also, if you want to see the rainfall estimates that our river forecast centers develop each day, it's not shown here, but you can go to water.noaa.gov/precip, PRECIP, and that'll take you directly to that information as well. There's functionality within NWIPS once you go to one of these links to limit the data that's displayed just to that boundary. So if you just want to see Alabama or you just want to see Georgia and you don't want to see anything from the other states, there's a button you can click on the right that limits the data to that boundary and will remove everything outside. You can then bookmark the link that ensues and it will come up just the way you want it every time you bring it up. Next slide. And finally, I must mention that we are on social media here at the Water Center. All our products get posted to social media. And also our OWP outreach team, Office of Water Prediction outreach team, is also providing more general messaging when things are less hydrologically active. So they'll provide little snippets of information, this day in flood history type stuff, just so that there's something out there, even on the quiet days, to be able to have engagement and follow us on social media. And with that, I believe that's all I have. I'm happy to take any questions you may have now or anytime in the future. And as I mentioned at the start, if any of these topics piqued your interest and you want to know more, reach out, and I promise you we've got more information we can provide. I appreciate it. Thank you very much.
Okay, good morning, everybody. Thank you so much to our presenters, Jason, Shelby, and Chip, for all this great information. Again, my name is Elliott Wickham. I am the Southeast Drought Early Warning System Coordinator for NOAA's NIDIS. Please, if you have any questions, go ahead and put them in the Slido app for our presenters. And our next webinar will be August 25th. Topic is TBA at the moment, but we have some pretty good ideas coming up for that. And I will also say, before I get into a question here that's there, if you have any questions about the webinar or specific information that was in this webinar, feel free to reach out to me at elliott.wickham@noaa.gov. Jason, I know we have one specific question in the chat right now, and this is for you. So how do the Weather Prediction Center excessive rainfall products and the National Water Center flooding products complement each other?
I have a slide about that I didn't put in this presentation, but I'll basically summarize it. There are times where I think both should be used right alongside each other because they do complement each other. The excessive rainfall outlook is the percent risk of exceeding flash flood guidance within 25 miles of a point. That's very valuable information. The flood hazard outlook is the potential impact if that flooding materializes, which is also very important information. There are times that you should probably use one of those two outlooks, times you should use the other one, and times you should use both. For example, for the event that's going on today, or potential event today in the I-95 corridor in the Mid-Atlantic and Northeast, I would lean more heavily on the excessive rainfall outlook. We don't really know the overall impact of what may happen yet, but we know there's a significant risk of something occurring in that corridor. We don't know exactly hydrologically where that's going to fall yet. So that makes it hard for the flood hazard outlook to really depict it in a significant way. There are other events, for example, the Washington State atmospheric river event or a hurricane in the southeast, where it's a lot more predictable for what area may be affected, and the potential impact is a lot more certain. And that makes it where you can look at both products. And then there may be some river flood events where you may just look only at the flood hazard outlook. So to me, they both go together. They both sort of share different information, and the excessive rainfall outlook is an input into the flood hazard outlook, one of those 25 considerations that I mentioned earlier, or 40 now.
Awesome. Thank you so much, Jason. That's fantastic information. We have one more question. This is probably geared towards Shelby. It's related to with the potential for the strong El Nino event continuing through the next couple months for the spring. What are the thoughts for Florida or North Florida and South Georgia flooding, at least as the information that we have right now?
So the El Nino will, of course, meander north and south as it causes the jet stream to produce rainfall, and we'll mostly be looking at most of this precipitation to be during the winter months, so October really through January, February timeframe. So I don't really have specifics on what the flooding may look like, but I can say that we do typically see I believe it's over. We see our normal amount of flooding that we would see during that period, and then maybe an additional 50 to 100%, I believe. I don't remember those percentages right off of hand, but we do see elevated flooding during El Nino periods.
Sweet. Thank you so much, Shelby. We have one more question. This is probably geared towards Chip, although I can chime in too if you want me to, Chip. Are we looking at more potential severe droughts in ongoing years, or does this look like an anomaly?
I mean, it's really hard to say, as we're projecting into the future. We know with the warming climate that we're more drought prone, and that we're certainly seeing more of these what are called hydroclimate whiplash events, where we get flooding and a lot of rain and then it gets dry. All that's consistent with climate change. And so on the basis of that, I would say we would be seeing this more, but details of that we can't figure that out at this point.
Thanks, Chip. And I'll also add too that drought is a normal part of the Southeast climate. In the more recent years before 2025, the last decade or so, our droughts have been more short-term flash drought focused. That's kind of what we've been dealing with. But prior to that, the early 2000s, that decade, the Southeast went through some multiple multi-year drought events, and so that is a normal part of our climate. We just haven't experienced them in the more recent years. So while it's been a while since we've had a long-term drought, that doesn't mean that we won't experience them in the future as well. It's the normal part of what we experience in the Southeast. All right, I don't see any more questions. And so with that, I'll give maybe another moment to let anyone else throw in something if they want to. But if nothing else pops up here in the next moment, I will close us out. So I'll give it one more moment. And while I give it another moment, I just want to say thank you again to Jason, Shelby, and Chip. Thank you so much for joining us today and giving your presentations and all this wonderful information. Again, if you have any questions, they all have their emails in the slides, which will be on the recording. But you are more than welcome to email me if you want me to get in touch with them if you have any questions as well. My email is elliott.wickham@noaa.gov. Thank you, everybody, for tuning in. I don't see any more questions, so I will go ahead and close the webinar. Thank you all for tuning in, and we'll see you next month. Thank you.